okay? We are extending what we have learned, so you don't need your Chromebooks out or anything like that. We're just going to extend on what we have learned and learn some new stuff as well, okay? For those of you that are listening to this video, what we're going to be doing at 9 o'clock, so in about 20 minutes, y'all are going to hear us start doing lockdown drills and stuff like that. But then you can just fast forward once we get through those. Cool? Okay, cool, thanks. So, nothing like talking to the computer, right? So, we are going to be factoring, like I said, it's in addition to what you've already learned, okay? So, what you have learned is difference of squares. What you were exposed to and didn't really use was the perfect square trinomials, because we just said you can just factor like normal. What you have not learned is sum of difference of squares. Okay? Go ahead and write this formula down. There are two of them. Notice how there's a sum and a difference. Okay? We only had difference of squares because you can't take the square root of a negative number. I mean, you get imaginary, but you can take the cubed root of a negative number. So that's why that is an option.
I'm gonna have to memorize this one.
Yeah. I'm going to walk you through the way that I remember it, so that way, hopefully,
Is there a
it'll help
song and
you.
dance to go with this too?
Do what?
Is there a song and dance to go with this too?
No, I mean, I could, hold a note and, make a melody and harmony and wow. Oh, wow. Things are getting interesting.
That wasn't terrible.
It wasn't terrible. It wasn't terrible, but I also didn't know where it was coming from.
We were waiting for you.
I didn't know where we were going. Were we trying to match pitch, or were we this?
I was trying to harmonize and can't hear it.
Okay.
I didn't do anything.
What? Oh, that's Liam. I couldn't. Not King.
Okay, so how do I remember this? Okay, you don't have to know, you don't have to do it my way, but this is just the quirky way that I remember. If it helps you, great. If you figure out another way, great. But what we're going to be looking at is just like, let's do plus, just like difference of squares. When we find the square root of things, this one we're finding the cube root of things. I'm dealing with A and B, okay? So what I'm going to look at is, again, weird, but I'm just rewriting the formula, but I'm walking through how I remember it. I write a short set of parentheses and a long set of parentheses. And in my mind, I know I'm going to write both of them down. I'm going to square the first one. I'm going to multiply the two together, and I'm going to square the last one. Okay? Weird. I'm like, okay, write them both down, square the first one, multiply them together, square the last one. Okay? Now, the signs, you might have heard people talk about it, but this is called the SOAP formula. How does it get to the name SOAP? This is the same sign as this one right here. This is the opposite sign of this sign right here. And this one's always positive. Okay? Notice at the top here, same sign, opposite sign, always positive. Okay? Do what?
No, that is.
That is how you spell it.
Is it?
Yes, that is
I thought it was-
exactly how you spell it.
Oh, I thought you said. Oh, I thought it was with you. Oh, that's Sue.
I did laugh. I don't think that's going to be a joke.
I wasn't even joking. I thought that it was spelled with you. I was like,
All right, same sign, opposite sign, always positive. Wow. I can't spell either, but that was a whole nother ballgame.
That's not how you spell stove.
Okay.
I'd rather be the super question.
Good bite. Always up, positive, meaning you're up. Okay, cool. Okay, so that's just how I remember. All right. If you want to memorize the formula, go for it. If you want to come up with some other saying, go for it. But you have to know this formula.
Can I
Okay.
say during the test?
In your head. Okay, so let's look at, we don't need to do those. Let's look at our first example. X cubed plus 64. Okay. So I'm going to look at this and I'm going to ask myself the question, what's the cubed root of x cubed? X. Just like the square root of x squared is just x. The cubed root of x cubed is just x. What is the cubed root of 64? 4. 4 times 4 times 4 is 64. So when I say my first one, I'm talking about x. When I'm talking about my second one, that's 4. Okay? When you hear me say those words. All right, so I draw my short set of parentheses, my long set of parentheses. Okay, I write them both down. I square the first one. I multiply the two together. And I square the last one. Okay. Now the SOAP formula comes into play here. And then I say the same sign as what's up here. That's what I'm referencing. So the same sign, opposite sign, always positive. Now, with this particular formula, you cannot factor it any further than that. Okay? You will never be able to factor the second set over here. So if you had to solve this problem and find the zeros, you would set x plus 4 equal to 0, which would just get you x equals negative 4. But then you would always have to do quadratic formula to the second one. Always. Okay. So if you had to solve, we would get x equals negative 4. And if we had to solve here, this is always going to be the quadratic formula. Okay. But once this is factored and once you memorize that crazy formula, it doesn't go any further than that. Okay. So let's try another one like that, but let's do, before we do that one over there, let's do x cubed minus 8. Also, these I handed out to y'all. If you can read them on your own time, but it's basically talking about online stuff. No cyberbullying, no whatever. Okay. I'm supposed to read over them with y'all, but
What did you just say?
we got a lot going on today.
What did you say about that? No. I'm cool.
Well, one believe it.
That was longer than I thought. Sorry. And so I could ask myself the question, x cubed. The cubed root of that just gets me x. And the cubed root of 8 is just 2. And I have my short set of parentheses, my long set of parentheses. I write them both down, square the first one, multiply them together, square the last one. And so, same sign, opposite sign, always positive. Okay? However you have to memorize that formula, you have to have that memorized. So I had one of my former students actually had him in both Honors Algebra 2. He doubled up and took my Honors Pre-Cal the next semester. So he said, thankfully, the emphasis on this formula, because he said, not only did you teach me it in Honors Algebra 2, you taught me again in Honors Pre-Cal, and it popped up in calculus. So if you're going that route, it's staying with you the whole time. So you might as well treat it like the quadratic formula where I just gotta have that thing memorized. Okay. So let's try this one up here now, number 2. Be careful, because now you have a coefficient. Okay, what's the cubed root of 8x cubed? Okay, 2x. And the cubed root of 27? 3. Okay? So when I am doing this particular problem, I have to be super careful. So if I write 2x and 3, if I square the first one, what does that actually equal? What? 4x squared, okay? When I square 2x squared, that 2 is involved. So that's 4x squared. I multiply the 2 together, and then I square the last one. Same sign, opposite sign, always positive. Okay? That is 100% a new formula for y'all. It's one you have to get familiar with and used to, okay? Any questions about sum and difference of squares, or cubes? Sorry. Okay? So let's look at some more types of factoring. Actually, let's knock those out. Let's try these 2. I know it's not a typo on the first one. The reason why that first one's up there is because of the test. I have released, not this past test, but the test before it. Y'all can see your score and which ones you missed on the graph and quadratics test. And then I think I had my last student take their missing test today. So I will release last test to y'all as well, so you can also see what you missed in your grade as well. Okay, so for the first one, that's difference of squares. Okay, so I can take the square root of 9x squared and the square root of 16, and it's a minus sign, I'm good to go. Okay, so the square root of 9x squared gets me 3x, and the square root of 16 gets me 4. And then I add them together and subtract them together. Okay, so again, I told y'all that was going to be one of the most missed questions on the test, and y'all provided. Okay, so do not forget about the smaller ones. Those are the ones y'all have a tendency of missing. Okay, what is the cubed root of 125? 5. So we have x and 5. Square the first one, multiply them together, square the last one. And same sign, opposite sign, always positive. The more you do of those, the more you're going to remember that. Okay?
Soup.
Or soup.
Never.
Any questions on those?
Doesn't Jonah look strikingly like Sonic?
That's just so not good.
Silly me, I should have said any math questions. All right, so one other way you'll forget to factor is the beginning thing, is taking out the greatest common factor. So go ahead and try both of these examples. Factoring out the greatest common factor. That should be your first step for every single problem.
All right, faculty and students, at this time we are going into our soft lockdown drill. So continue teaching, just stay in your classrooms.
What is my greatest common factor in the first one? 2x. Are we done? No, that can be factored further. You're always going to do that. Okay. So factors of -15.
As part of our drill, we're doing a medical emergency. I need the emergency response team to report to hallway A. We're going into a medium lockdown. Everybody get out of the hallway and lock your doors. This is a drill. Continue to teach.
Please
Yeah, this is
do
just a
your
drill.
Not
It's
being
not like
fed
having
at all.
students having a heart attack in the hallway.
So why not?
Lock the doors.
Didn't have to scoop up any
Yeah, we're
kids.
not on a medium. one.
Okay. All right. Yeah, this is one of those where it's like medical emergency or when y'all like to do extracurricular activities and the puppy dogs have to show up. It's another one of those situations. But yeah.
I didn't get that until a second ago. I was like,
The puppies.
I can't know.
The puppies that like to sniff things. They have to show up.
No, because they used to bring dogs.
Weed dogs.
Not the sweet ones that you pet.
Yeah.
I thought you meant like the ones that come to lunch.
No.
No,
No, these are the ones that have to sniff things.
Oh, okay.
You know, canines.
Dark dogs. Okay, what were your factors at -15? I got you too. All right, thank you. Someone's listening. How did I get -15? 3 times -5. Okay, so I would suggest with this problem, worry about that 2x later. You have to write that with every single step. It gets confusing with everything you're doing and you might accidentally leave it off somewhere, but if you bring it all the way down to where your answer is going to be, you don't have to worry about it the whole time. Okay, so if I break apart the middle, because I cannot do the shortcut here. All right, factor by grouping, I can take a 3x out. I can take a 5 out. And I have an x minus 1 and a 3x plus 5. So for me, if I leave that 2x down there, I don't have to worry about forgetting it or anything of that nature. Okay. Any questions on that one? A lot of these are review, but we're now in polynomials, so that's why I'm making sure we go over them. What can we factor out of the next one? Anytime you can take out a negative, go for it, okay? It's going to make your life so much easier if you don't have to deal with that. Can I take that one any further? No. But y'all on a test would make it happen somehow. Okay? So if it cannot go any further, that is completely factored. We're so used to doing more work that when we get one that we don't have to do as much work, we don't know what to do. Okay? So factoring out greatest common factor. Any issues with that? Okay. Let's keep going until they tell us to be quiet. Even though you've already seen the first part and you've already seen an answer. Anyone that did not see that or know, how would we approach a problem like this? How do we approach this problem? Do I?
Like old wolf.
Wait, what?
He said you back away slowly.
Back away slowly. Okay.
Split up into 2.
See, if there was another problem that I felt like you needed to do that too, I would totally say that. This is not one you need to back away from.
Split it up into binomials and factor it.
What did we call that? The splitting up part.
Big boy.
Games.
Okay, someone that saw the word, what was it?
Example.
Are we your favorite class? You have a, you have a second day.
Was it suit?
What was the word that was up there? What have we been doing 100 times? Factoring, by,
Square root.
Yeah,
y'all have already lost my virtual kids. They have moved on. They have fast forwarded and they had said, I'm done.
Most of them don't even watch the videos.
Well, thank you.
I saw Caden and he only he was on a different Caden and he talked to me and he said that he only watched one of the videos and he swore to never watch another one because solely because
Caden, you were just ratted out. I hope you're watching this. Let me know if you hear this part. If not, I'm going to take 50 points off your grade.
Gonna see this.
Interesting. Okay, so yes, we're going to factor by grouping.
I won't see him Thursday.
All right.
We are now moving into the hard lockdown drill. So doors are locked, doors are covered.
Quiet.
Everybody stay quiet in the classrooms. And lights are off. Turn your lights off, lock your doors, cover your windows,
Try to distance as much as you can.
and be very quiet. Everybody out of the hallway.
And then hit the deck. You gotta be on the ground. No phones. Absolutely quiet. Y'all second to get this ready for work. Okay. Just one, please.
right, at this time, you can resume normal teaching and normal movement throughout the building. Thank you.
All right, thank you guys. That was awesome. All right, great job. This is absolutely no joking matter, but I really do wish y'all could have seen me when the lights were out and my eyes weren't adjusted. I was like,
You should have seen me
and then I came over here and I was like, okay, I'm
Now,
just
why would
gonna
you
get
unlock
ready.
Because there was no room for me to sit down because I'm a large person. So I just had to sit there and squat.
Why would you just go like this? Like, why are you on your platform?
Because there was no space and I didn't want to make any noise.
Okay, but thank y'all. Y'all did great. You were quiet. You were respectful. Thank. So thank y'all for doing that. Okay, so factoring by grouping. We're gonna group the first two together, group the last two together, just like we've done all of those other problems. Same steps. Take out the greatest common factor, and so on. Go ahead and finish this one out. Of course, we always ask ourselves if it can go any further than that. If it can, great. If not, don't worry. That's your final answer. Okay. Any questions about factoring by grouping? No, we've done a ton of them, but there could still be questions. That's why I don't want you to get intimidated when 4 terms pop up and you don't know how to approach it, because you do know how to approach it. So that's why I said it's not one I'm back at. Fine. All right. So, yes, that's the answer, but we'll get to it here in a second. We are not substituting another variable. Sometimes people get really confused with that. We're just going to keep it simple. Okay? So in polynomials, we're dealing with higher exponents than just x squared. Okay? But this looks very familiar to what we've already been doing. If you ever see the combination of x to the 4th and x squared, you're just going to do it just like we've been doing every single problem. Okay? So whenever you see that combination of x to the 4th and x squared and then a constant that looks just like a quadratic, that's what you're going to do. Okay? So for the long version of that, I'm going to walk you through that, and then we'll do the shortcut version. Factors of 1 that get me -2. What are they? -1, -1. So what I can do is I can split apart the middle, but instead of writing just 1x, I'm splitting apart x squared, so I have to write 1x squared. Okay. Factor by grouping. Take out an x squared. I'm left with x squared minus 1. I can take out a -1, and I'm left with x squared minus 1. So that's if I wanted to do it the long way. But if you notice, the leading coefficient was 1. So I could have done the shortcut at the beginning. Factors of 1 that get me -2. -1, -1. I just have to put x squared instead of x. Okay. Am I done? Huh? Yes? No? Am I done with that problem? I'd say no. Okay. That's the difference of squares right there. Square root of x squared. Square root of 1. So instead of writing this out twice, because that would be kind of silly, If I'm factoring just this one, that's gonna be x plus 1 and x minus 1. But if I factored this one out too, it'd be the same thing. So I'm just gonna make these squared. So x plus 1 squared and x minus 1 squared. Okay. Try the next one. Same idea. You can do the shortcut, you can do it the long way. But as long as they are written in that format, you're good to go. So the factors of 64 that get me negative 16 are negative 8 and negative 8. So if I do the shortcut, or if I did the long way, I'd get the same answer. So am I done? No. That's difference of cubes. Okay. So if I'm going to find the cubed root of x cubed and the cubed root of 8, that's just x and 2. So I have x and 2, x squared, 2x, and 4. Same sign, opposite sign, always positive. But because I have 2 of them, I'm just going to make them squared. Okay? There's no sense in doing it twice if it's the same exact thing. All right, any questions about that? Am I going too fast on those? Okay. All right, go ahead and try these 4.
Why do they get to just play musical chairs every day?
Upstairs.
Yeah.
Dude, let's just like stomp on the ceiling.
Well, so that.
If I was upstairs,
Let's get
I
like some
just felt like a
broomsticks
bunch
and
of,
just-
yeah. Banging on the floor, I feel
Make sure you're doing all 4 of these. Okay, who wants to walk me through the first one? Okay,
You factor out an x from both sides.
okay,
So that's 16x squared minus 25.
okay,
Difference of squares. So that's x, 4x minus 5, and 4x plus 5.
perfect. Don't forget, when you are factoring and you factor out a greatest common factor, that has to stay. Okay, what about the second one? Who wants to walk me through the second one? Okay,
You take the cube as well, so 54 is 4x.
Then plus 3.
okay,
Alright.
And then,
16x squared minus 12x plus 9.
okay. What about the third one? Okay,
So you group them.
all right.
You would take out 2x squared from the first group and then negative 3 from the second group.
So what am I left with from the first group?
4x plus 1.
Okay, and you said I take out what?
Negative 3.
Okay, and I'm left with what?
4x plus 1.
Okay,
And then you just set that up in factor form. So 2x squared minus 3. And then 4x plus 1.
awesome. Okay. And our last one. Anybody got the last one?
I've been pointing at you the whole time.
I didn't respond. I can be a very patient person. Okay,
Okay, so you just start off by looking for your greatest common factor, which is 6. You
Okay.
factor that out, and you get x squared plus 12x plus 20. And then you look for the two factors that equal 20 when you multiply and when you add. And
Okay.
16 and so you get 6, and then in parentheses, x plus 2, and then x plus 10.
awesome. Okay. So we had difference of squares, sum of cubes, grouping, and then taking out the greatest common factor. So that's a lot of what we did today, except we didn't have one of the fourth ones up there. Okay. So one more thing we need to talk about, but are there any questions about those four that I can answer? Okay. One more thing. You already have this slide in your notes, allegedly, when we did the complex conjugates. Okay. You have a plus bi, you have a minus bi. Now we're looking at it in the form of zeros of a function. So you cannot have one without the other. All right. If you have 3 plus 2i, you have to have 3 minus 2i as another 0. Okay. And you'll see why when we start multiplying here in a second. Okay. If you have a plus bi, you have to have a minus bi. They go hand in hand. They cannot be separated. Okay. So I could give you a problem like this on your homework, which I don't know if that's the same homework there. That's why I'm deleting that. I can give you a problem like this on the homework, and I tell you to write this in factored form. Well, I see a negative 2i up there. What else has to be there? A positive 2i. So they want me to write this in factored form. If they say factored form, you say thank you. And I'll show you why here in a second. So if I want to write 1 as a factor, how would I write that? X minus 1, good. Same goes for 3. I would write x minus 3. And the same thing goes for the imaginary ones. I would just write x plus 2i and x minus 2i. If you were to multiply these out and you still had an I in your answer, you're wrong, okay? That's why the complex conjugate has to be there. Because when you actually find the polynomial that fits this, there doesn't need to be an I in there. So that's why we do the complex conjugate, because remember the I disappears when that multiplication happens. So those always happen together. So if they say to leave it in factored form, like I said, you say thank you. But if they say to write it in standard form, you gotta multiply that out. And that's what you're gonna do, okay? What I would suggest to do, I would multiply these two together first. Then I'd multiply these two together. And then I would multiply your answers together. So, however you want to approach that, go for it. I'll meet you on the other side and see if you got it right. I want it in standard form. These types of problems have a high, what's the word I'm looking for? A higher chance of making mistakes just because there's a lot of little details. So make sure you're paying attention. Try not to look up here until you're done. Anybody get it? Of those of you who got it, did anyone put y equals?
Now it is.
Always in the habit. Always, always, always in the habit. Y equals. It's an equation. We have found the equation. We have found the polynomial in standard form. Just have it. It needs to be there. So like I said, huge room for error. Forget a little negative, add wrong, multiply instead of add. It happens, okay? So again, take your time when it comes to problems like these. All it is multiplying. But again, that's when mistakes happen, okay? Any questions on if you are given the zeros of a function and you're forced to write it in standard form? If you notice, if you only had one of the complex numbers and you multiplied this through with this, for my virtual kids, if you multiplied just this by this, you would have had an I in your standard form. An I doesn't exist in that standard form there, okay? So you always want to make sure you multiply it by the complex conjugate. Okay? Any questions on that? Cool. Let's start our homework.